students, in the previous class I am discussing about index funding using nonlinear programming method. In this class I am going to explain Markowitz portfolio model. This also comes under nonlinear programming problem category. After that I will explain its variants of this Markowitz portfolio problems. So, the agenda for this lecture is Markowitz portfolio model and its variants. Harry Markowitz received the 1990 Nobel Prize for his path-breaking work in portfolio optimization. This professor, an economics professor, Harry Markowitz, received Nobel Prize portfolio model, which I am going to discuss now. So, the Markowitz mean variance portfolio model is a classic application of nonlinear programming. In the previous class, in the index funding, we are concerned about only the mean return rate. We did not bother about the variance of the portfolio, but in the mean variance problem, the mean variance portfolio model, we are going to consider both variance and mean of the return. So, in this lecture, we are going to discuss about Markowitz mean variance portfolio model. Numerous variations of this basic model are used by money management firms throughout the world. What are the assumptions in Markowitz model? The assumption is the risk of a portfolio is based on the variability of returns from said portfolio. So, what I mean here is the risk is measured by the variability of the returns. What is the variability? It is nothing but the variance of the return. Okay. Then an investor is a risk averse. His assumption is that an investor will try to minimize or avoid risk. The investor's utility function is concave and increasing. So, utility function will be in this shape, What is the meaning of this? It is a concave and increasing. So, what is happening? How can we explain this one? See, this is the straight model. So, what is that? Is utility is decreasing after when the variable in x is increasing. Beyond that, you see that the utility is increasing, after that the utility is decreasing. And the analysis is based on a single period model of investment. We are considering only one model and one period. The investor either maximize their portfolio return for a given level of risk or minimizes their risk for a given return. That is why we are calling it mean variance theorem. An investor is rational in nature. A key trade-off in most portfolio optimization model must be made between risk and return. So, we need to have the trade-off between risk and return. So, in order to get greater return, the investor must also face greater risk. The index fund model of the previous lecture managed trade-off passively. What is the meaning of this trade-off passively? We did not consider the variance of the portfolio, we have considered only the mean of the returns. Okay. We did not consider the variance of the return, we have considered only the mean of the return. An investor in the index fund we constructed must be satisfied with risk return characteristics of S&P 500. He has to consider the risk and the same time and the return also. Previously we have considered about only the return. Other portfolio model explicitly quantify the trade-off between risk and return. In most optimization models, the return is used as the expected return or average of possible outcomes. Suppose return 1, return 1 2, return 3, the return means the average of this return, otherwise the expected value of this return. Then we discuss about what is the mean of the return. Consider the example developed in the previous lecture. There was a 5 scenario. So, 5 scenario represented the possible outcomes over a 1 year planning horizon. The return under each scenario was defined by the variable R1, R2, R3, R4 or R5 respectively. That means, for year 1, if the scenario 1 is repeated, the return will be R1. The next year, if the scenario 2 is repeated, the return is R2, like this R3, R4 and R5. If P is the probability of scenario among n possible scenarios, then the expected return for the portfolio R bar is sigma of P s multiplied by R s. So, S equal to 1 to n. So, there are 5 scenario. So, what will happen? This will be P 1 R 1 plus P 2 R 2 plus P 3 R 3 plus P 4 R 4 plus P 5 and R 5. This P 1 represents the probability of scenario 1, P 2 represents probability of scenario 2. So, we are giving the common name P s, probability of scenario. R s is that corresponding return if that scenario is occurring. So, the mean of the return in that expression, the P s, we have to find out the value of P s. What is happening if we assume that 5 planning horizon for the company are equally likely, then the probability of each scenario is 1 by 5. That is why we have written 1 by 5 for each scenario. So, the mean of the return will be 1 by 5 sigma s equal to 1 to 5 R s. The next one is we have to find out the variance of the return. So, measuring risk is a more difficult. The measure of risk most often associated with Markowitz portfolio model is the variance of the portfolio. So, we are measuring the risk by the variance of the portfolio. If the expected return is defined by the first equation, what we have discussed there, that is R bar, the portfolio variance is variance equal to sigma s equal to 1 to n P s R s minus R bar whole square. It is simple, our variance formula. We know traditionally sigma of P s x minus x bar whole square. Here x bar means your R bar, x means that corresponding return, P s means the probability. For the example problem which you have discussed, 5 planning scenario are equally likely. So, instead of P s we can replace 1 by s R s minus R bar whole square. So, this is the expression for our variance of the portfolio. The portfolio variance is the average of the sum of square of deviations from the mean value under each scenario. Okay. The larger this number, the more widely dispersed the scenario returns are about their average values. If the variance is higher, that means there are more spread in their returns, it is a more risk. If the portfolio variance were equal to 0, then every scenario return Ri would be equal. So, that means in every scenario you are getting equal return, that means there is no variance, variance is 0. Fundamentally, there are 2 basic ways to formulate the Markowitz model. There are 2 ways we can formulate the Markowitz model. One way is minimizing the variance of the portfolio subjected to a constraint on the expected return of the portfolio. So, we can minimize the variance. What is the constraint? The expected return has to be achieved. Otherwise, we can maximize the expected return of the portfolio subjected to a constraint on the variance. Okay. So, there are 2 things there, variance, another one is return. One thing is that we can minimize the variance, the return has to be achieved, there is a constraint on the return. Otherwise, what we can do, we can maximize the return, but the variance has to be minimized or it has to meet the constraint. But in this problem what we are going to say, we are going to consider the case 1. What is the case 1? We are going to minimize the variance of the portfolio. Okay. So, the objective function is that we are going to minimize the variance. Okay. Already we have seen what is the constraint. The constraint is the expected portfolio return to be at least 10 percentage. So, when we say the return the expected, that means R bar is greater than 10 percentage. The variance has to be minimized. Now, this is in a complete model. You see there are 10 equations. The equation 1 represents the objective function, the 2 represents scenario 1. Okay. So, 10.06 Fs, this is a portfolio 1, IB, LG, LV, SG, SV. Okay. And the sum of proportions Fs, IB, LG, LV, SG, SV should be equal to 1, and you see that we are finding the mean of the return. So, PS sigma of RS, then that the mean should be greater than or equal to 10 percentage, okay, 10. So, the constraint on this expected portfolio return is R should be greater than, actually it is R bar should be greater than or equal to 10. So, the complete Markowitz model involves 12 variables and 8 constraints excluding the non-negativity constraint. Now, I will explain the formulation of this Markowitz portfolio model. The objective function for the Markowitz model is to minimize the portfolio variance, that is why we are minimizing. Equation 2 to 6 were the present in the index fund model present in the earlier lecture. The 2 to 6 in the previous lecture also we had the same thing. These equations define the return of each scenario. Equation 7, which also present in the index fund model, it requires all of the money to be invested in the mutual funds. So, this constraint is often called the unity constraint. That means, the money, the amount which we are having, all the proportions, some of the proportions or some of the probability should be 1. Equation 8 defines the average return, expected return R bar, which is expected return of the portfolio. Equation 9 represents the portfolio return to be at least 10 percentage, that is a constraint. Finally, expression 10 requires a non-negative investment in each mutual fund. Now, I am going to solve this problem with the help of solver, then I will come back to the result. Now, I am going to explain the Excel model of this nonlinear problem. The first one is the objective function. So, the E6, look at the objective function, this is 1 upon 5. So, it is a 0.2 R1 minus R bar whole square plus 1 upon 5 R2 minus R bar whole square and R3 minus R bar whole square plus R4 minus R bar whole square and the last one plus R5 minus R bar whole square. So, for that you need to have the mean, that is R bar. So, R bar is written in as E18. So, see the E18, E18 is the mean of the return. What is the mean of the return? R1, R2, R3, R4, R5. So, you see E12, E12 is R1, E12. See that formula E12, sum product of F10 to M10, F12 to M12, that provides the R1, that is the right hand side of our constraint. Okay. And you see here the L10, when you see L10, yeah, L10 and E18. okay, because we are going to write one constraint there, that I will explain with the model. So, go to data, so solver, yeah. So, see this problem is minimization problem, and one constraint is that the sum of the probability should be 1. You see that the E10 equal to L10. So, what I am saying that the expected value of return is equal to our R value, okay, that one constraint I have written. And another one, the L10 should be greater than or equal to 10, that is the expected return should be at least 10%. Okay. Now, I am solving by nonlinear method. So, when I solve it, press OK. Now, this 27.13 is my variance. Now, I got the value for Fs. What is the Fs? So, 15% of our amount should be invested on Fs. So, 52% of your amount should be invested on IB, 4% of our amount should be invested on LG, LV you need not invest, SG you need not invest, and 27% of your amount should be invested on SV. So, the average return is 10. So, this constraint also achieved. Now, will I interpret this result in the lecture. So, the objective function value is 27.13. So, F10 is a 15%, G10 it is 52%, 4% and 27%. So, this says about your expected value of our return. So, further interpretation is the minimum value of the portfolio variance is 27.136. A portion of the solution for this model using a required return of at least 10% appears in the figure. So, this 10%. This solution implies that the clients will get an expected return of 10% and minimize their risk as measured by portfolio variance by investing approximately 16% of the portfolio in the foreign stock, this one foreign stock fund, and 53% in the intermediate bond, this one, because the value of IB is 0.52, and 4% in the large cap growth, this one fund, and 27% in small cap value fund, here 27. So, this is our proportion of portfolio that we need to invest. The upper and lower bound on the amount of an asset type in the portfolio can be easily modeled. Notice that the solution given in the figure has more than 50% of portfolio invested in the intermediate term bond. You see this one. Okay. It may be unwise because we are investing 52% of our more than 50% into a single security. It may be unwise to let one asset contribute so heavily to the portfolio. Hence, the upper bounds are often placed in the percentage of portfolio invested in a single asset. We can introduce some more constraint that will make a restriction on investing in a single asset. Likewise, it might be undesirable to include an extremely small quantity of an asset in the portfolio. So, there also we can introduce a new constraint. Thus, there may be the constraint that require non-zero amounts of an asset to be at least minimum percentage of the portfolio. So, how we can have the upper bound and lower bound of each asset? We can introduce a new constraints that can be incorporated, that will take care that the minimum amount or maximum amount is invested into the portfolio. The Markowitz model provides a convenient way for an investor to trade off between risk and return. So, in x axis I have taken return, in y axis I have taken portfolio variance. So, we have solved this problem for 10%. So, what we can do, we can vary these values. What we can do, we can start from 8 to 12. Okay. For suppose the required rate is 10%, return is 10%, we can see what is the variance. See that suppose the return is 12%, you see that the variance is increasing. So, the figure graphs these minimum portfolio variance versus required expected return, as required expected return is varied from 8 to 12 percentage, an increment of 1 percentage. What we can do in our problem, what we have discussed here in this model, we can change this R bar, instead of 10 we can put 11, 12, 13, 14, then we can capture the variance. That is what I have done it here. Okay. So, each point in finance, this graph is called efficient frontier. So, what is efficient frontier? In x axis expected return, required return, in y axis portfolio variance. So, each point on the efficient frontier, so each point, okay, in the efficient frontier is the minimum possible risk. How we are measuring the risk? By variance, portfolio variance for the given return. So, by looking at the graph of the efficient frontier, an investor can pick the mean variance trade off that he or she is most comfortable. So, this graph efficient frontier is giving the trade off between return and the variance. It is up to the investor. Suppose if I am picking here, my return will be 11 percentage, but my variance will be more than 30. Okay. So, this efficient frontier is a useful graph that will suggest the trade off between return and the variance. So, now we will be modifying this problem, then we will solve it. So, previously what we have done, we are given our result is in terms of percentage into different assets. But assume that now I have some money, say money is I have assumed that I have $50,000. So, this $50,000, how much amount has to be invested on each asset? Okay. So, that is the portfolio model variations. So, in the Markowitz portfolio optimization model defined in equation 1 to 10, the decision variables represents percentage of the portfolio invested in each of the mutual fund. What is the meaning of that? For example, if when I say Fs equal to 0.25 in the solution means that 25 percentage of the money in the portfolio is invested in the foreign stock mutual fund. Now, it is possible to define the decision variables to represent the actual dollar amount invested in each mutual fund or stock. So, when we say the actual dollar, we are so comfortable instead of saying percentage. So, what we can do? We can redefine the decision variables so that now each variable represents the dollar amount invested in the mutual fund. So, this is little more practical applications. So, this was our own problem, previous problem. Here FSIB represents the 10.06 represents the percentage. Okay. Here the return also more than 10 percentage, but now we are going to consider the actual amount. What is that? Assume an investor has $50,000 to invest and wants to minimize the variance of his or her portfolio subjected to constraint that the portfolio return minimum of 10 percentage. So, what we will be doing now? We will reformulate the model, that is all the equation from 1 to 10 based on the new definition of decision variables. Only thing is the definition of decision variable is changed. What is that? Previously it is a proportion, now it is the actual amount. So, this problem we are going to solve with the help of solver. Now, you see the formulations. So, here now everything is in terms of, see that previously I put 10.06, now it is 0.1006. Okay. You see that previously it is 1, now it is $50,000 because $50,000 I am having. So, how much I have to invest on Fs, how much I have to invest on IB and so on. Okay. So, the R bar is the expected rate of return should be R min. So, the R minimum should be greater than or equal to 5,000 because the 10 percentage. So, 50,000. So, 10% of 50,000 is $5,000. So, now we are going to solve this problem. Okay. Then we are going to get the result in terms of the actual amount invested in each asset. Now, I will explain the Excel model of this problem. So, when I keep see the C5, the answer is that is the we have to minimize the variance. Okay. The minimize the variance, that is 1 upon 5. So, that is written 0.2 RS, that is R1 minus R bar whole square, 1 upon 5 plus R2 minus R bar whole square. What is R bar? R bar I have written C18. So, when I keep my cursor on C18, that is a mean value C12 to C16 divided by 5, the mean value of that return. So, that mean value I are going to use in my objective function. When I go to data and solver, look at the constraint. The E17 is 50,000. So, E18 should be greater than or equal to L10, but the L10 is 5,000. Okay. When I solve it, so the answer is, you see FS 7920. So, out of $50,000, $7,920 has to be invested on FS. $26,273 should be invested on IB. So, $2,103 has to be invested on LZ. Otherwise, what we can do, the previously we got the percentage, that percentage has to be multiplied by 50,000, both are same, you will get the same answer. Now, we will go back to my presentation. So, this is my variance. So, this is the amount which has to be invested on F10, that is that asset. So, this is this much amount has to be invested in another stocks. So, the sum of the amount should be 50,000 and the minimum return is 5,000 is guaranteed. In this lecture, I have explained the mean variance portfolio model of Markowitz. I have taken a sample problem that I have formulated with the help of Excel using the knowledge of nonlinear programming. Then I have modified the problem by considering the actual amount that has to be invested in each portfolio. In the next class, I will discuss about some more applications of nonlinear programming model. Thank you.